You know, everyone is talking about the massive AI gold rush that's happening right now. But if you look back at history, the people who made the most money in a gold rush weren't always the ones digging for gold. Nope, it was the folks selling the picks and shovels. So today, we're going to look at who's forging the tools that are powering this entire AI revolution.
And it really all boils down to this one question. What in the world does a secret, custom-built AI chip have to do with the next trillion-dollar market? Well, the answer connects the tiny, microscopic world of silicon with the massive, sprawling future of our entire economy.
And just to give you a sense of the scale here, look at this quote. We're not just talking about another little tech trend. Experts are calling this a fundamental sea change. They're saying it's bigger than the internet. And that feeling, right there, is the reason for the mind-boggling investments we're about to see.
And here is the proof in dollars and cents. $200 billion. That's the combined amount the big tech giants, the Magnificent Seven minus NVIDIA, are planning to spend in 2024 alone. And here's the kicker. Pretty much all of that cash is going straight into AI infrastructure. They're not just buying some software, they are literally building the foundation of this new world from scratch.
Okay, so let's zoom in on one of the biggest players building their own tools. We're going to talk about Meta and the super high-tech, custom-built shovel they've engineered to dig for all that AI gold. This is where that whole abstract idea of AI infrastructure gets very, very real. So this is the shovel. What you're looking at is the blueprint for Meta's second-gen AI chip. It's called the MTIA-2, that's for Meta Training and Inference Accelerator. Now, you can't just go out and buy one of these. It was designed for one thing and one thing only, to perfectly run Meta's most important AI jobs, like the recommendation models that decide exactly what you see on your Instagram and Facebook feeds.
And what's just wild is how fast they're moving. I mean, look at this. From their first chip to their second, they more than tripled the performance. They doubled the on-chip memory. This is not some tiny little upgrade. It is a massive, massive leap in raw power. It just goes to show you, Meta isn't just dipping their toes in the water here. They're going all in on scaling their own custom hardware.
Which, of course, brings us to a huge strategic question. Why would a company as massive as Meta go through all the pain and expense of building their own chip? I mean, why not just buy the best ones on the market from a company like NVIDIA?
Well, the answer really comes down to control. When you buy off the shelf, you're at the mercy of somebody else's supply chain, and you're using a tool that's made for everybody. But when you build your own, you control everything. You can fine-tune the hardware to work perfectly with your software, and that can lead to incredible cost savings and performance boosts. It's really about owning your own destiny in this race.
But let's be super clear about this, it is not easy. Not at all. Meta's own papers talk about the gritty, painful reality of getting a custom chip to work at their massive scale. They had to figure out all sorts of gnarly problems that you'd normally take for granted. Things like handling memory errors, finding out how far they could safely push the chip's performance, and even fixing actual bugs in the silicon with live software updates. It was a monumental effort.
And this graph right here, this shows you exactly why all that pain and hard work was worth it. This chart shows the performance you get for the total cost of ownership, basically the bang for your buck. And you can see their custom chip actually started out worse than a standard GPU, but through all that relentless, gritty optimization we were just talking about, it became almost twice as cost-effective. They made their shovel not just work, they made it way, way cheaper to run than the best thing they could buy.
Okay, so we've gotten a close-up look at Meta's custom shovel. Now it's time to zoom back out. How does all this super technical, in-the-weeds hardware stuff connect to that huge, futuristic vision that's making companies spend $200 billion?
Here's the key insight. The hardware is the foundation for everything. And the AI models themselves, the LLMs, they're becoming a commodity. Just like having a .com website became normal in the 90s. The real long-term value isn't just having an AI, it's about the crazy, revolutionary things you can build on top of it.
And that leads us to what might be the ultimate application. This quote just frames it perfectly. The endgame for creating all of this artificial intelligence. It isn't just about having smarter chatbots. It's about giving that intelligence a physical body to interact with the real world. And this is what that future might actually look like. All of that incredible computing power from chips like Meta's, that's the brain power you need to run not just one, but millions of autonomous robots all working together in a world that was originally built for us humans. So who are the big players getting ready for this future? It's not just about who can build the smartest AI model anymore. It's about who can build the entire stack,
from the silicon chip all the way up to the robots themselves. And you can see a few different strategies taking shape. You've got NVIDIA, who's basically the ultimate arms dealer, selling the picks and shovels to everyone. Then there's Amazon, taking a more practical approach, building specialized robots that solve their problems today in their warehouses. And then you have Tesla, taking the biggest swing of all, trying to build a general-purpose humanoid robot, a vision that, if they pull it off, could change the very nature of work forever.
So we end up right back where we started, in this incredible new AI gold rush. The biggest players are forging their own tools, from these secret custom-made chips to these grand visions of robotic workforces. And it really leaves you with one final question to think about. When you look at this landscape, who do you think is truly building the future?